Hi folks, let's just talk about a little bit about customer segmentation. It's a very old thing. It's just not it's something new, but still it's very important because every business has their customers. Every business has its customer, and they have to segment the customer and then the entire customer base and target to take actions, right? That's why customer segmentation is pretty important. Still, it's important, and many guys think about and working on very hard in this topic. But unfortunately, we do not have much understanding of what the customer segmentation is and customer segmentation techniques and procedures. Thus, I just prepared a mini example custom segmentation process and the results. It should be fictitious, but uh, hopefully you could get some essence of this tutorial and my advice of regarding this custom segmentation. There are lots of different approaches available to deal with custom segmentation. Doing custom segmentation has to be very efficient in some senses, but some guys really want to make it accurate and sophisticated. Depends on your goal and your objective. Custom segmentation. This process can be very different from one guy to another. Uh, there are two different approaches. These are the major approaches. Using one choice is using grid-based approaches, and the other could be, and the other might be applying clustering, sort of clustering kind of techniques like K-means or DB scan or something like that. We'll deal with K-means and K-prototype in the tutorial session here, but mostly focus on the grid-based approach first. Okay, customer segmentation actually is the process or the practice of dividing customer base, the entire customer, into some meaningful groups of individuals that are similar in specific ways, in some ways you choose, relevant to marketing or customer management. There is no cure solution though in custom segmentation. Uh, that is why you have to study and I have to give you some advice here. Depending on your goal and depending on what and where to use the result from the customer segmentation is a variety of different. There is hundreds of thousands of different approaches are available and could be utilized for customer segmentation. That is why we have to check the fundamentals first. Here is very simplified version of steps for customer segmentation. You have to first define the goal of segmentation and then collect and prepare data set to be used in this segmentation. Then you have to start explore the data set, understand the data set and customers' traits or overall entire as a group. Select the approach to apply is the next thing. Then using that approach, you may develop a set of rules or a model to segment the select customers for each group. Then after this segmentation, the step E is the segmentation itself, and then after that step, you have to understand what has been done, what you got from the segmentation process. That for that you have to profile the resulting segments you made. Evaluate the segmentation based on your predefined goal in the step A. That is pretty important. If you got one segmentation result from all those steps, then you have to get back to the goal definition stage in the first step. Okay, describing the results or documenting, prepare a document describing the results and some insights were gathered, collected from found from the stages, all the stages, small or big, whatever, from analysis and natural language. Anybody can understand. To make it easy to understand is very important here in the last step. Okay, well then, let's just start to talk about the process with some example data. We have to load the data first. This is step A and B. The data set is from, it's sort of fake, okay? I created the data set, but I assume that this is a sort of online retailing company. Let's just call it something like getwhatever.com. Let's assume that this is online retailer, online shop, shopping mall shop, which sells everything, literally everything in the world, okay? Which sells a variety of items in different categories, assuming that you already finished a bit of preliminary processing, in short, pre-processing to aggregate and to create the candidate input variables and some variables for evaluation of customer segmentation results. Okay, let's just import the libraries, and then now there is something to note. That notice that this is a jittering user-defined function. I will explain something about a little bit about this function later on. Okay, we got two functions. Our jit one is actually it is a jittering function, jitter, and our jit3 is two, and we set the path. The data is in this GitHub site, in my GitHub site, and using read_CSV, we retrieve the data from the GitHub site. The name is dfc20ds.csv, and we'll put the data into dfc 50. Okay, it contains 6,000 fake customers, and then we have 11 columns in here. We defined this variable to set the list of features from this data frame dfc 50. Here's the data sample: customer ID, sex, gender, and age, and how much they bought in Nike category. And here, Nike is not just a brand; it's just a category. It's a category. Amount H&M purchase amount, Starbucks amount, and digital device amount, and book amount, and amount to spend for hotel, and amount in total past year and count how many times the customer spend money in the website shopping mall. Then let's move on to the next stage, explore. Because already we imported the data, we have to understand what is in the database and what's the pattern in the database in a basic level understanding. To make those basic understanding, we prod a little bit to think about the patterns. Okay? Doing some this kind of EDA, so-called EDA, exploratory data analysis, is to understand the data and the customer base, the structure. Okay, some insights from this exploration stage. We can select and choose the right approach to be applied for custom segmentation. Let's just pick a little bit of just focus on this small number or very limited number of categories: Nike, Starbucks, and books. Okay, we have only 3 columns: features and dimensions, candidate inputs, and to customer segmentation here in the initial stage. Okay, maybe you might be able to change later on. Okay, to expand your analysis. And next step is comparing the distribution of categories. To comparing this category by category difference, we make a histogram using pandas, using matplotlib, columns, and alpha. This option is for making it transparent a little bit. Then we can see the 3 different categories distributions in a single chart. The blue one is amount Nike, and the orange one is amount Starbucks, and amount book is in green. What do you see in the plot? The scatter plot. Oh no, it's a histogram, an overlaid histogram. This histogram shows that Starbucks guys in this category, many of the entire customer base, many of the customers, they use a lot in Starbucks category. Most of the guys spend at least a little bit in Starbucks category. Okay, the next one is the second one is Nike, and people never read books and they don't spend a lot in book. Okay. The next step is visual analysis. To understand the one-on-one cross pattern, we draw a series of scatter plots here. Employers either tools to use combinations, okay? Because we have 3 different features that are categories. That is why we use combinations to generate the pairs of 2 different categories. Actually, they are features, combinations of features. Okay, and that is why we make combinations, and then we just choose some of them, length of 2, because we can make a scatter plot with just 2 independent variables. Okay. To make it simple, a little bit concise, I had to write a loop, create a loop to plotting one and then next one and the next one for each combinations of features, I draw this scatter plot. Take a look at this one. Among Nike, here is the dimension x1, and among Starbucks, this is the dimension x2. Thus, this shows the first combination. Okay. Let's think about. Let's check take a look at the patterns here. Most of the guys, a lot of guys do not even buy Starbucks and both an amount Nike 2 or 0. There are quite many guys are here, but they are not sort of majority. Or the guys use as one of the items, the categories. Some are here, they both bought Nike and Starbucks, but spend very much in both dimensions, both categories, quite rare here, as you see here. Okay, and the next pair, Nike and Book. Book is not that popular in that, at least in this shopping mall, right? Compared to Nike, is quite different, huh? And Starbucks. So many people these days go to Starbucks to drink coffee, get a coffee actually, and they grab the coffee and then go out and go somewhere around. Anyway, many people buy something. I noticed that this is a fictitious data set. Okay, don't forget to remember this is fictitious. This is fake. Okay, but let's just for a while be serious about this. Okay, let's just believe this is the real one. Anyway, another dimension is the categories of features regarding customer database. In the customer database, most of the customer base has this kind of demographics variables: age, sex, and the region, including region, and then we call them geodemographics sometimes. Anyway, let's just check the two variables, age and sex. And one more thing, the most important thing, total amount purchased, total amount spent in the website. Okay. Here, age 27, that customer is female and spend 20 and something. Okay. This is the amount. Actually, it is in Korean won in terms of currency, so maybe you can be a little bit confusing, but don't think about it too much. 209, 209, it can be nearly similar to, a little bit, or roughly similar to the US dollar. So just think 209, 108, 8, 26, 226, 221. Okay. Customer by customer, there is a difference in spending amount in total. Okay. And there is the structure and the content of this table data frame. And then let's just check a little bit about this demographics related characteristics of this data set. For this purpose, we just check the histograms first. For the case of categorical variable like gender, female or male, education or location or region, then it's impossible to use histogram. That does not mean anything. you have to use some other approaches to assess the results, assess the distribution and composition. Okay, check the take a look at this histogram. Uh, most of the customer, uh, the majority of the customers are quite young, huh? Between 26 and 28. Yeah, this shows the peak, and so relatively old. They are actually young though, but there are people here around 32 and 33. And there are two different groups. Huh? There is a cutoff point. Interestingly, there are a very small number of people here, around 30. You know, it is actually fictitious. Don't think too much serious about this. Anyway, we found two major groups in age groups, and male and female. Yeah, there are a small number of male customers, so many female customers in here. About 5,000 and 1,000, so 5 times more female customers are here. And the next chart, actually, it is a sort of scatter plot, but it's just like a box plot, quite similar to box plot. I decided to, I've I often use this kind of scatter plotting here. Take a look at this. In x-axis, sex, you know, x-axis represents sex, and the y-axis is age. Within this, using this two-dimensional space, in the two-dimensional space, we plot every customer as a point. Here are lots of points. Okay, then we may easily visually understand that many customers are female. Okay, and the red color tells you that it's a high spender, spending more than the amount of median. Okay, they could be relatively higher spender. So let's read the scatter plot. Male customers, they are a small number of group, they are not that big, and female customers, a big group, and roughly around 29 or something, there are quite inactive groups, low spending groups, and for male customer group, there are some, according to the age, there is a difference. 26 to 28. In this relatively young male group, does not spend. They spend a lot, and some old guys, old boys actually, they spend a little bit less than the youngsters, the younger ones. Here are something interesting. Getting older in the female customer group, the spending is increasing. But if it's less than 27 or somewhere, their customer group, in female customer group, the good spenders, high spenders are here. Okay? We understood that overall patterns, okay, demographics, that matters. That matters. That is related to customers' spending in terms of amount, total amount, and there is a categorical, category by category difference in spending patterns. Okay? Then it's time for us to make decision about what to use as segmentation approach. We can decide to only use a grid-based simple approach for just demographics or transactions by categories, or we can build a complex, relatively a little bit more complex clustering-based methods or other solutions. Let's assume that we chose two approaches. One is simple grid-based, category by category. We'll pick some small number of categories, and then we make a grid to segment the customer base. And cluster approach will put in a couple of handful of variables to the cluster-based solution. The next step is grid-based segmentation. Let's just getting into the segmentation stage. This is probably this is the core step, and you guys are interested. Most of you are interested in this step. Okay, let's just assume that because they are the most popular among the three, actually, but Starbucks, that was the number one most popular, the most frequently used. Many guys used in this category, and Nike was the second. Thus, we select two popular categories. Here, we choose two categories and the total amount of spending for profiling purposes. We often use this syntax to this kind of grammar in Python to divide groups up, create a group for this dimension if it's greater than median. We'll paint it, the point I mean, with red color. In other cases, we'll use blue color. And to make it easy to understand the density at the same time in the scatter plot, we use alpha parameter very low. I set very low to make it a difference when there is an overlap. And to make it the points, in the scatter plot, to make points smaller, so we could get this kind of plot. Since we have 6,000, it's a small data, but compared to the real world data set, but most of the times we use the samples like 100,000 or 200,000, those kind of small sample. But if think about it, if you put all those points here in a single plot, scatter plot, then it could be quite confusing to understand the pattern because all those spaces are full of points. That is why I apply alpha parameters and size parameters. This is the resulting scatter plot. You know, among Starbucks, yeah, there are lots of guys who go to Starbucks, okay, and among Nike pair of shoes, that is important, right? So many guys go to Starbucks, yeah, all those things, all those guys, and some customers, just some portion of the customer base, they buy and they spend a little bit of Nike for Nike, okay? But the color shows that spending in the both dimension is desirable, okay? Here, red ones are here. But we chose the grid-based segmentation. You know, grid-based segmentation is doing something like this. You pick one dimension and then you split the space into two, okay? And then you split again in the next dimension. Then you can get some divided areas, the subset areas from the entire whole space. So it's a sort of decomposition based on the, heavily depending on your visualizing, visual understanding from the scatter plot patterns. Based just solely on your visual understanding, actually it's mine anyway. And you know, there is a big difference between the group below 20,000 and above 20,000. Okay, so it's a red place and this is blue place, hot region and blue region. Then we can easily pick, this is the cutoff point threshold, 20,000 in spending amount of Starbucks. Then the next step is the second dimension. We'll check this here. The axis shows the amount of Nike spending. So let's moving down. Your eyes are here, and maybe you can clearly see that there is something a little bit of change here. So it's roughly about 45,000. Then you can draw a line here. You set these two as the threshold or cutoff point. Okay? Now vertically, you used 200,000, and horizontally, you chose 45,000. Let's consider that this is your choice. Then what would you do? You create a new scatter plot in the same points, but you color the regions like this. You know, actually, most of the guys above 45,000 of Nike spending, all those guys are in red, in color, okay? And in this region, Starbucks, and some, regardless of Nike spending, many a bit more spending in amount of Starbucks spending, this group have this good, relatively red compared to this group. There is a difference, but compared to the group above here, these two a little bit different, right? It's all red, it's a little bit red, it's mostly blue. Okay, we can define this three as customer segmentation using grid-based and also visual, right? Visual understanding based as grid-based segmentation. Okay, then we got the rule. We have three distinctive groups. Okay, above 45,000 Nike group and under 45,000 of Nike, there are two groups among Starbucks above 20,000 and below 12,000. Okay, thus that's why we have three distinctive customer groups. We apply this uh, in coloring the scatter plot. So this is the big bug group. We named this group as big bug, and we decided to call this group colored in orange heavy coffee group and not much group, spending nothing in both dimensions. Okay, it's not that appropriate to call nothing. Okay, uh, maybe I have to call this or less at least one of the dimensions. Okay, then we may call this group as not much group. How many customers are in each group? Number of customers in the customers clusters. Not much heavy coffee, big bulk. You know, we have a very stupid or tricky data set that's many guys go to coffee. So many guys are in this group belongs to this group. And big bulk also is a good. This group is a very small group, but very important group because they spend a lot. At least they buy some Nike and some other, and they spend some other things too. Thus, they are a very valuable group. Not much. It's about 40%. However, they do not spend a lot. You know, we've been working on based on your intuition and data distribution, scatter plotting, and dividing using a insight-based, visual insight-based cutoff point. We've last we've found these three unit groups. Let's go back to here. Don't you think this is important and meaningful? It's clear. You discovered the important clusters of customers. These things are this kind of grid-based and visualization-focused approach is quite rough, very rough actually, but it's quite similar to the. It's nothing bad. It's no bad. It's not worse than very sophisticated approaches using neural network or class-based solution, whatever a complex solution. Because while defining the cutoff and selecting the dimensions, key dimensions, and naming and profiling, you do all these things, and while doing this, you input your understanding about the business you're in and you're dealing with. That is very important. That makes this kind of quite subjective approaches uh, produce very great, sometimes wonderful results. Then now is now let's just take another kind of approaches to one of the popular choices k-means in clustering based segmentation solution. The first step in k-means clustering, you have to decide what kind of variables to be used in your clustering process. So here we chose age, sex, Nike, Starbucks book, and at the same time we decided to include that amount in total. But however, there is a problem, there is an issue. K-means algorithm does not handle categorical variable. We have gender variable. This is a categorical type. You remember? It was just like this. Female. It is labeled as categorical variable. Then what did you do? There's no choice but to encode this to convert the categorical variables to encoded numeric variables. So I define this new variable as is female. When the sex is coded as F, then we'll assign 1, and other cases will assign 0 as value to this variable is female. That is why we have 1s here. Okay. Then we don't need sex, which is in categorical data type. We don't need this anymore. So we drop this. We'll use all these numeric variables at the moment from now on for clustering. Now it's time to build a cluster model from second-lens clustering input. We input k-means, and then we create a dataset file. We use this, copy, and then we use this. Making a copy is because we have to do something. We can maybe change the name of the dataset columns or adding some additional variables derived from somewhere, or cluster code can be inserted into this data frame. That is why I try to make a copy of the data set that we've selected. And then we run the model using k-means function, and we define the number of cluster. K-means, while using k-means, you have to set the number of clusters you want to get. Okay, and to prevent the random variation of the results, we set the seeds using random under seed options. The KMM1 is a skeleton of the k-means model we want to create, and fitting we'll put the data in to this model skeleton. We input X. Where's the X? Actually, there somewhere there is X. maybe we have to change the 4KMM instead of X. Okay, okay, it'll run, and the same results here. Okay, it has to be because there were X somewhere in this script notebook. Sorry. We trained the model, so KMM1 has an instance, okay, model's instance. Then this is a model. It's not a skeleton, not trained, so we can get labels, custom labels, and count from the model, and we store those two into cluster label and cluster count, customer counts. And frequency should be here. And define vectors representing clusters, okay? And the colors. Maybe we can make 5 clusters or 10 clusters, whatever. So we need to, for visual inspection purpose, we have to have, it's better for us to have some colors for each cluster. Does the colors, this variable has the list of color labels: yellow, blue, and green, red. But actually we'll create only, we create only 3 clusters, so we'll use all this from all these things. We'll use just the 3. Okay, and then let's just draw a bar chart. Cluster label, that's the x-axis label, and cluster customer counts. This should be the value for the y-axis, and we'll color using the cluster by cluster color code. Here are some, here are the results. Let's check this. Number of customer by clusters. Okay, let's define yellow, blue, and it doesn't look like yellow because it has, maybe it has a little bit of something, so it looks a little bit different from the defined color, but it's because of the monitor. And yellow, blue, and green, these 2 are the customer groups K-means generated, created. We can easily see that cluster 0 has many customers, and cluster number 1, this group has a relatively small number of customers. And profiling will be aggregated for each group. Will be aggregated with the mean function. Using the mean function, we aggregated each variables to understand what the group means. Cluster 0, they are in between the age values of each of the clusters, is in the middle. This group, cluster number 2, is relatively old guys and young guys, but the difference is not that big. Among Nike, oh, there is a big difference here, and among Starbucks, wow, quite different. Among the 3 clusters, female customer proportion, cause 0.1 for each customer, and then we aggregated using mean function. We got proportion of female customer in each group. So 82% females are in here in this group cluster 0, and 72% is in cluster 1. There are 72% of the customers in the group, the members are female. Relatively small number of females are here, and nearly 90% of customers are female. Yeah, quite female-like customer group is the class number 2. The problem is we already prepared the profile table, but we have already 1, 2, 3, 4, 5, 6 different features here, dimensions. So as a human, you're not that you feel some difficulty in comparing these different dimensions at the same time, because you have 6 dimensions. That is why we draw a chart like this. Okay. In here, we call this radar chart. In here, you can compare and understand the difference between among the 3 clusters. Now, their traces are here, summarized in here. Okay. As you can easily find that in the radar chart, cluster number 2, oh no, cluster number 1, the second group, cluster number 1 is here, looks like this. They are strong in many dimensions. Most of the dimensions they are strong, excluding the ratio of female. Okay, there are lots of male groups, male customers belong to this group, with cluster 0 and cluster 1 compared to the cluster 0 and 2. These 2 groups are different from cluster 1 in terms of a female ratio. They have higher female customers in there. And one interesting pattern is in amount book. Some group never spend a lot, or near 0, never spend a lot in book category, that is cluster 0, and many ladies. And cluster number 1, cluster 1 is in between those 0 and 1, 2. Okay? This group, cluster 1, buys books too, but this group, cluster 0, color red, they do not spend a lot in book category. Notice that we have more than 3 dimensions. Okay? Remember, that is why we have to introduce this kind of new style, a little bit different kind of chart. It's not just a decoration, because we have many dimensions. To compare and understand the difference among the groups, we need the entire features at the same time. That is why we introduced this. Okay? To know when to use and where to use each visualization tools, each of the visualization tools is pretty important. Or sometimes you cannot select the right tool, or in other cases you can pick the wrong solution. That is why we have to check and remember this experience. Okay. To check the profile in detail, we can use this humans to interpret the detailed result. We can create a series of scatter plots comparing age and amount Nike and amount Nike and Starbucks, just like this. All these two are showing a scatter plot using two different dimensions pair, and the color shows the cluster. Okay, the blue group for a relatively small number, but they're pretty important actually. They spend a lot in total, and they spend a lot in Starbucks. The important blue groups here are some yellows and others, including green ones. How about this? Let's take a look at this. Nike and Starbucks. So these two are important. We know this. Uh, we learned this from grid solution analysis. Wow, there are lots of big bulk guys, some small bulk guys, just like this. Okay, and notice that here are interesting groups. They do not buy Nike, a little bit of Starbucks, but they are spending a lot of group. Maybe this is because they spend other than the chosen categories too. I'll take a look at other things too. Okay, this is interesting, and you have to check this. Okay, amount booked and amount past year. What you see, the clusters are quite distinctively separated in the scatter plot. Amount past years, the value of amount past year is big, then they almost always belong to the amount the stronger, blue group, big buck group. What does this mean? Maybe we can find out from this pattern. There is a possibility. We can know that there is a possibility that clustering results is heavily based on amount past year. Then what is the mechanism to make amount past year the most important feature in making clustering solution? I figure out that I think that maybe amount past year has the scale is big, and that is why the amount past year has big impact on making multi-dimensional clustering results, because the scale is big. In k-means clustering results, big difference in one dimension, that will impact a lot, and the total amount that is way too big compared to other categories have very big impact. Okay, Another chart also shows this, the same pattern. Female, ratio of female does not have any, compared to amount past year, does not have any impact in defining the cluster. Okay, we'll clearly see that there's a blue group and green group and yellow group. Thus, we have to do some further analysis, post-segmentation analysis. This is an additional section. This is to understand the determinants of the segmentation result. We introduced decision tree to understand what is the segmentation results. Well, we had to use this as classifier, right? We had to use this as classifier. Let's just change this right away. Classifier. Oh, there was typo, sorry. Okay, it works, and then we've got the result. The differentiate decision tree, find the rules to differentiate the clusters, the groups, on past year. This is the entire group, and then we find that there are lots of customers belong to more than 243 past year spending. These are spending a lot group, and these are spending less group. There's, the first cluster is about 30,000. Maybe it is number 2, cluster number 2. This is cluster number 2, okay? And this is probably cluster number 0. Number 2, number 1, number 1, number 0, number 2, right? Okay. Green, blue, red, yellow, green, red, yellow, blue, green, right? Yellow, blue, green. And that was the sequence in that order. It has to be in this yellow, blue, green. Yellow, blue, green. Okay. Yellow, blue, green. Yellow, blue, green. This is the majority group, huh? Yellow, blue, green. Blue, what is the blue? What is the blue group? In terms of purity, we can call a late node or in the intermediate node a group of some color. 860, 843, 815. Okay, this is the blue group, and this is the yellow group, and this is, no other guys are here in different colors, only blue, only, what was that? I forgot it. So maybe we have to check the color names. YBG. Okay, let's just not forget this. you add comment here, then we'll never forget. Okay, let's make it like this. Now we can clearly understand the blue group is here and yellow group, the majority group, is here. They don't spend a lot. They don't buy books. They don't spend a lot. They don't buy books. The property of this group is buying nothing, huh? Or buying a very small, buying very less. And blue group, the most important group, is here. They buy so much. And there's the only characteristic. Okay, the same thing. Past year, past year, past year. Then what does this mean? They buy a lot. That is all. That is all. This is the only characteristics of this group, those high spenders. And in between the two groups, there is another group. What the heck is going on here? Amount. Then they are less much spending group compared to this group, but there's no other characteristics. Okay? And this group buys both of this category and both in books and in total in both dimensions they spend less. These are the characteristics. Anyway, we can find that past year amount in total amount is pretty important. It rules. This feature rules all this here and here and here. Only somewhere, very small reasons, amount book is a determinant. Amount Starbucks, for some very small reason, it also is. It has some impact. But past year, book, and Starbucks, those three, and here Nike. Some of this kind of variables has a little bit of impact, but the most stronger determinant is amount past year, the total amount. Amount past year is total spending. We define that way, so including all the categories. Then, if the segmentation is okay for your goal of executing actions, it's totally dependent on what the goal of yours is. But if you don't like this result, then you have to do something. If it's not what you want, what would you adjust? What will you change in the procedures in all those jobs? One possibility is, in a possible solution is to rescale before clustering, or another case, maybe you can ignore, exclude from the data set the amount past year that represents the total amount. It depends on you, and it's time for you to study or have discussion with other guys to decide what to do. Until here, we've been working on quite a long time, right? We've been working on these things: customer segmentation, using a fictitious customer database. We analyzed in many different ways, and when we checked in visual way and applied clustering algorithm, K-means, and another choice is K-prototype algorithm, which is combining K-means and K-modes. While using K-prototype algorithms, you can use, you never have to exclude categorical variables, or you never have to encode and to transform the categorical variables to numeric ones. There is a great advantage. Anyway, if you apply this solution, the techniques, then you'll get a different answer from clustering. Okay? Clustering mixed attributes using K-prototype algorithms are here. We call K-prototypes and then apply K-prototypes function to our data set to make 3 clusters: education and area. Those kind of different new variables could be easily included because we use an algorithm that is built in to automatically deal with categorical variables. Let me just, I'm going to go here very quickly. The results are like this. Area, the location of where you live, is included in the clustering process, and it has a little bit of impact in making the result of segmentation. So this group, cluster 0, has many customers who live here, but let's compare with group 2, cluster 2. Incheon actually, it's hard to find anybody lives in Incheon in group number 2. So we can see that area in here has some impact in producing the final results of clustering, because we used K-prototype algorithms. Actually, this also is a categorical variable, even when they have only 2 classes. So we can easily encode it to 0-1 scale. Education, university or PhD or college, whatever, it has a little bit of impact. Okay? There is a difference among, we can find difference among the clusters. This is why we use cluster solution that is capable of dealing with categorical variables too. Anyway, I was a little bit quick about K-prototype and relatively quick about clustering using K-means algorithm. But anyway, wrapping up, categorical variables and numeric variables, these two are, both of them are used together in K-prototype algorithm. This algorithm has an advantage compared to K-means algorithm, which uses more often, which is used quite often, and that does not handle categorical variables. Applying encoding methods, you can deal with this, avoid the limitations, but it's just not an automatically possible thing. Feature encoding, take a look at some other things in supervised learning models. There are lots of materials describing feature encoding methods, and you can apply the encoding methods to here to convert categorical variables to numeric variables. Okay, the final words are clustering might be used for EDA to identify the structural composition. And oftentimes, clustering is used for building models to segment. Well, the main topic of this tutorial is the segmentation of customer base. And in other cases, you can use clustering techniques to build a good recommendation. And one more thing to remember is accuracy in clustering especially does not mean very important thing when it comes to clustering. Accuracy, what does that mean in clustering? It's unsupervised learning. Everything is depending on you, and your input decides what to be produced. The results, the setting the right way to get the result, cluster result, is just depending on you, just up to you. Double check is the must for you to compare the result and the predefined goals in the initial stage of the whole customer segmentation process. That's all. Okay, thank you. Maybe possibly or probably